Welcome students. Today we will move to the next exercise, exercise 6b. All of you read the first question from the exercise. Find the cardinal number of the following sets. First one is given as A1 is equal to set of all -2, -1, 1, 3, 5. Okay. So what do you mean by the cardinal number? What we learned? Cardinal number is a number of elements in a set, isn't it? What is a cardinal number? The number of elements in a set is called a cardinal number. Cardinal number of an empty set is 0, isn't it? So we know the number of elements in the given set is a cardinal number. So here set is given. What is a cardinal number? Count how many elements are there. 1, 2, 3, 4, 5. So the cardinal number is 5 here. How to write? How we can represent the cardinal number in notation? We can use n of A1. That means, what is the meaning of this one? Cardinal number of the set A1 is equal to 5. Now the second question. Second question from the exercise. A2 is equal to set of all x such that x belongs to n and 3 less than or equal to x less than 7. Okay. So here the set is given in the set builder form. So first we have to find out the elements of this and represent the same set in the roster form. Then only we are able to find out the cardinal number. So how we can solve? A2 is given as set of all x such that x belongs to n, 3 less than or equal to x less than 7, isn't it? So which all elements? 3 less than or equal to x less than 7, that is a condition, and x is a natural number. So which all elements will come? 3, 4, 5, 6. So how many elements are there? 4 elements. So what will be the cardinal number? It will be equal to 4. Now A3 is given as a set of all p such that p belongs to w and 2p minus 3 less than 8. Okay, so here the condition is 2p minus 3 less than 8 and p belongs to w. P belongs to w means that p is a whole number. Condition is 2p minus 3 less than 8. Find out the values of p from this inequation. So first, how to solve an inequation? You learned that in last year. Okay, so minus 3 is there, so add plus 3 on both sides, you will get 2p less than 11. Then divide by 2, so p less than 11 by 2, that means p less than 5.5. so which all are the whole numbers less than 5.5? 0, 1, 2, 3, 4, 5. Okay, so what will be n of a3? N of a3 is equal to 6. Hope it is clear. Now fourth question. A4 is equal to set of all b such that b belongs to z and minus 7 less than 3b minus 1 less than or equal to 2. So here b belongs to z means b is an integer and minus 7 less than 3b minus 1 less than or equal to 2 is a condition given. So from that, first we will choose this part. Okay, and we will solve. So minus 7 less than 3b minus 1. Okay, now what will be the value of b? That you have to find out from here. So I added plus 1 on both sides. So minus 6 less than 3b you will get. Now we have to find out the value of b now. So this 3 also we have to cancel. So divide both sides by 3. So minus 2 less than b you will get. One side you got. Let it be there. Okay, now the right side. This part you have to take. This part you have to take now. 3b minus 1 less than or equal to 2. So 3b minus 1 less than or equal to 2. Add plus 1 on both sides. So you will get 3b less than or equal to 3. Now this 3 we have to cancel. Okay, so divide both sides by 3. So b less than or equal to 1 you will get. So now this and this you have to combine. So how you can write? Minus 2 less than b less than or equal to 1. Like this you will get. So which all integers will satisfy this relationship? A4 is equal to minus 1, 0, 1. How many elements are there? 3 elements. So what is the cardinal number? 3. Now the second question. If p is equal to set of all p such that p is a letter in the word permanent, find n of p. N of p means what you have to find out? Cardinal number itself. So first we have to write this set in the roster form. So P is equal to PERMANT. These elements will come. How many elements are there? 7. So what will be the cardinal number? That will be equal to 7. Next, third question. State which of the following sets are finite and which are infinite. So what you have to do? Here 4 sets are given. You have to find out the elements of this set and have to express that in which form? Roster form. Okay, then find out whether it is finite or infinite. First one, A is given as set of all x such that x belongs to Z and x less than 10. Z means set of all integers. So which all elements will come? To the negative side it will infinitely go, and to the positive side less than 10. That means up to 9 only. So this side going infinitely means this is an infinite set. Now the second question, set of all x such that x belongs to W and 5x minus 3 less than or equal to 20. Okay, so the condition is 5x minus 3 less than or equal to 20 and x belongs to W. This x can take the values from the set of whole numbers. So find the values of x first. So you will get x less than or equal to 23 by 5. 23 by 5 means 4.6. Which all are the whole numbers which is less than 4.6? 0, 1, 2, 3, 4. Okay. So finite number of elements only there. So it is a finite set. Now the third question, if P is equal to set of all y such that y is equal to 3x minus 2, x belongs to n and x greater than 5. So here the condition is y is equal to 3x minus 2 and x belongs to n. One more condition is there, x greater than 5. Okay. So when x is equal to 6, value of y we find out. Then x is equal to 7, the value of y we have to find out. How to find out the value of y? Here instead of x you have to substitute the value. So 3 into 6 minus 2. Here when we take 7, 3 into 7 minus 2. Okay, like that all the values you have to give. So we got set P is equal to set of all 16, 19, 22, 25, etc. It is going infinitely because x can take the values which is greater than 5. Okay, so it is an infinite set. Okay, now the fourth one, M is equal to set of all R such that R is equal to 3 by N. N belongs to W. So N is a whole number, this one denominator, and 6 less than N less than or equal to 15. So that N can take the values from greater than 6 means smaller, equal to sign is not there. So 7 onwards only we are able to take. So 7 to 15. Okay, so that is limited. So find out the elements of that. When n is equal to 7, what is R? 3 by n, 3 by 7. Like that n is equal to 8, R is equal to 3 by 8. Then n is equal to 9, R is equal to 3 by 9. Like that find out all the values. Okay, so which is the set M? 3 by 7, 3 by 8, etc. up to 3 by 15 only. This finite number of elements only. So it is a finite set. Now we are moving to fourth question. Find which of the following sets are singleton sets. So here also what we have to do, we have to express the given sets in roster form. Then only we are able to find out whether it is singleton or not. Okay, what do you mean by singleton set? If there is only one element in the set, it is called singleton set. Okay, so here first question, it is given as the set of points of intersection of two non-parallel straight lines on the same plane. In how many points that two straight line will intersect? Only on one point, isn't it? So that is only one element. That means that is a singleton set. Second one, A is equal to set of all x such that 7x minus 3 is equal to 11. Okay, so this condition is 7x minus 3. So 7x you will get, find out the value of x, that you will get 2. Only one element. So what we can say, this is a singleton set. Like that, next question, B is equal to y is set of all y such that 2y plus 1 less than 3 and y belongs to W. This is a condition. Okay, and y is a whole number too. So solve for y, you will get y less than 1, which are only 0 is a whole number which is less than 1. So it is a singleton set. Now we are moving to fifth question from the exercise. Find which of the following sets are empty. Again, what we have to do, we have to express in roster form. Then only we are able to find out which all sets are empty. What do you mean by empty set? If there is no element in the given set, it is called empty set. Okay. So fifth one, first question, what they ask, the set of points of intersection of two parallel lines. Parallel lines never intersect, that we know. So point of intersection, no point of intersection will be there. That means no elements in the set. So first set itself is an empty set. Now the second one, A is equal to set of all x such that x belongs to n and 5 less than x less than or equal to 6. So from here 5 less than x, so this 5 we cannot take, more than 5 and less than or equal to 6. How many elements are there? Only one natural number, that is 6. So A is equal to singleton 6. Hence the given set is not an empty set because one element is there. Now the second one, B is equal to set of all x such that x square plus 4 is equal to 0. X belongs to n. Here the condition is x square plus 4 is equal to 0. Okay. So x square is equal to negative 4. X is equal to root of negative 4, which is not a natural number. We know that is not a natural number. So what we can say, there is no element. So B is an empty set. Then next, question number 4. C is equal to set of all even numbers between 6 and 10. Which all are the even numbers between 6 and 10? 8. One element is there, isn't it? So it is not an empty set. Then next, 5. D is equal to prime numbers between 7 and 11. Okay. There is no prime number between 7 and 11. So D is an empty set. Okay. Next we are moving to sixth question. Are the sets A is equal to set 4, 5, 6 and B is equal to set x square minus 5x minus 6 is equal to 0 disjoint? What do you mean by disjoint sets? For these two sets, if there is no element in common, we can say that two sets are disjoint sets. Okay. So first we have to find out the elements of the set. A is given as 4, 5, 6. B is given as like this. So this is a condition, x square minus 5x minus 6 is equal to 0. Okay. So this minus 5x we can write as minus 6x plus x. Now take x outside from the first two. So you will get x into x minus 6 plus 1 into x minus 6 is equal to 0. That implies x minus 6 into x plus 1 is equal to 0. What will be the value of x then? X will be equal to 6 or x is equal to minus 1. So two elements, 6 and minus 1 are there. 6 and minus 1. Now compare set A and set B. This 6 is here also. So what we can conclude, set A and B are not disjoint because these sets have an element 6 in common. Now the second question from that one. Are the sets A is equal to set B, C, D, E and B is equal to set of all x such that x is a letter in the word master joint sets or not? So A is this set, B is the letters of this one. So like this we will come. We will get the elements of the set. Now compare A and B. Joint because these sets have element E in common. There is a common element, so these two sets are joint set. They are also not disjoint. Now we are moving to the seventh question. State whether the following pairs of sets are equivalent or not. What do you mean by equivalent set? They will have an equal number of elements. That means you have to find out the cardinal number of the given set. If they are equal, you can say that they are equivalent set. First one, A is equal to set of all x such that x belongs to n and 11 greater than 2x minus 1. From that, which is a condition here, 11 greater than 2x minus 1. Okay. So from that to solve for x, you will get A is equal to 1, 2, 3, 4, 5, 6. Cardinal number 6. Now B, set of all y such that y belongs to w and 3 less than or equal to y less than or is equal to 9. Okay. So this condition you have to take and find out the value. You will get the elements in B as 3, 4, 5, 6, 7, 8, 9. So n of B is equal to 7. Cardinal number of the set A we got as 6 and cardinal number of set B is equal to 7. Therefore, the cardinal numbers are not equal. What will be our conclusion? Therefore, set A and B are not equivalent. Now, the second question. Set of integers and set of natural numbers, whether they are equivalent or not. Set of integers and set of natural numbers are equivalent because both these sets have infinite number of elements. Okay. Now, the third question. Set of whole numbers and set of multiples of 3. So, set of whole numbers and set of multiples of 3 are equivalent because both of these have infinite number of elements. Now, fourth question. P is equal to 5 is 6, 7, 8 and M is equal to set of all x such that x belongs to W, x less than or equal to 4. So, P is given directly the 5, 6, 7, 8, N of P 4. Okay. Now, M is given as this set. Which all are the elements? 0, 1, 2, 3, 4. How many n of m is 5? Now, n of p 4 and n of m 5. So, cardinal numbers are not same. So, they are not equivalent. Next, eighth question. State whether the following pairs of sets are equal or not. When the two sets will become equal, their cardinal numbers should be equal. Then one more thing. Two sets are equal if both the sets have same elements. Then only we can say that the given two sets are equal. The two sets should have the same elements. Okay, now eighth question, all of you read. First, A is given as 2, 4, 6, 8 and B is equal to 2n and belongs to n and n less than 5. So, find out the elements. First elements of the set. So, 2n. Okay. So, when n is equal to 1, 2n 2, n is equal to 2, 2n 4. Like that you will get the elements. B is equal to 2, 4, 6, 8. Compare A and B. Same elements, isn't it? So, what we can say? Elements of set A and set B are the same. Therefore, A and B are equal. Okay. Now question number 2. M is given as this set. So the elements of M you are able to calculate. So you will get 0, 1, 2, 3, 4. N is given as Y is equal to 2n minus 1 like this. So value of Y like this we can calculate. Take the values and find out the value. Substitute the value of n in this one and find out the values of y. You will get values of y as 1357. 1357. Okay. Now see m 0, 1, 2, 3, 4 and n 1357. The elements are not same, isn't it? The elements of set m and n are not same. Therefore, m and n are not equal. Next one, E is given as a set of all x such that x square plus 8x minus 9 is equal to 0. Now this one you have to solve and find out the value of x. Okay. So this 8x you can write as 9x minus x. Then from the first two terms take x outside. Minus from these two terms minus 1 outside. Now here x plus 9 is common. Take it outside like this you will get. Now find out the value of x. You will get the value of x as minus 9 and 1. Okay. So what is the elements of the set E? Minus 9 and 1. What they gave, f is equal to 1, 9 minus 9. Elements same now, order only different. So what we can say, the elements of set E and F are same. So sets E and F are equal. Now the fourth question from that set. A is equal to set of all x such that x belongs to an x less than 3. Which all elements? Elements 1 and 2. B is given as a set of all y such that y square minus 3y plus 2 is equal to 0. This is a condition given. Take that and solve for y. Okay, so here minus 3y you can write as minus 2y minus y. By adding this you will get 3y itself. Then from the first two terms take y outside and from the last two terms take minus 1 outside. Now this y minus 2 is common, take it outside. Okay, so you will get y minus 1 into y minus 1 is equal to 0. The This one is 0 only when either this one is 0 or this one is 0, isn't it? So either y minus 2 is 0 or y minus 1 is 0. So which all will be the values of y? Then 2 and 1. So B is a set 1, 2. Okay. So what is the conclusion? A also have 1, 2, the elements, isn't it? So elements of set A and set B are the same. Therefore A and B are equal. Now we are moving to the 9th question. State whether each of the following set is a finite set or an infinite set. What do you mean by finite set? Finite number of elements. If in a set there is finite number of elements, we will say that that set is a finite set. If in a set there are infinite number of elements, it is called a infinite set. So first one, the set of multiples of 8. Okay, set of multiples of 8. So which set it will be? So 8, 16, 24, 32, etc. That means it is an infinite set. Next one, the set of integers less than 10. Set of integers less than 10 means 9, 8, 7, like that it will go negative side, go infinitely. So it is an infinite set. Now the third one, the set of whole numbers less than 12. Whole numbers means from 0 only it is starting. So 11 to 0 only, finite number of elements. So it is a finite set. Fourth one, x is equal, set of all x such that x is equal to 3n minus 2, n belongs to w, and less than or equal to 8. So n belongs to w and n less than or equal to 8 means which all values? 0, 1, 2, 3 up to 8 only will come. These values you have to substitute here in this equation. So you will get the values as minus 2, minus 1, 4, 7, 10, 13, 16, 19 and 22. This much elements only means it is a finite set. Next, set of all x such that x is equal to 3n minus 2, n belongs to set, n less than or equal to 8. So set means negative side it will go infinitely. Okay, so the set will, you will get like this, one side it will go infinitely, so it is an infinite set. Now the sixth one, set of all x such that x is equal to n by 2 plus n plus 1, n belongs to w. Okay, substitute the values for this n and find out the set. It will go infinitely. Okay, so it is an infinite set. Next, 10th set, all of you just look into that one. Answer whether the following statements are true or false. Give reasons. Okay, so one only I will show, the remaining you have to do. The set of even natural numbers less than 21 and the set of odd natural numbers less than 21 are equivalent sets. So you have to list out the elements of that one. Okay, and what you have to do? Give the reason why they are. State whether it is true or false, then say. Now question number 2, if E is equal to factors of 16 and F is equal to factors of 20, then E is equal to F. Like this the statement they gave. We have to find out whether it is true or false. First question, just look like this. You have to find out the set of even natural numbers less than 21. Like this you will get. Cardinal number you will get as 10. Set of odd natural numbers less than 21. So this much. Cardinal number again 10 you will get. Cardinal number of sets, both sets are 10. That means they are equivalent sets, isn't it? Therefore the given statement is true. Like this you have to do. Okay. Now give reason. That question is there. That's why like this step by step we are writing and solving. Now the second question is equal to factors of 16 now. Yes. So like this you will get the set. Then F is equal to factors of 20. So like this you will get the elements of the set E and F are not same. Okay. They are said that E is equal to F. If the elements are not same, that sets are not equal. So it is false. Hope it is clear. The remaining questions you have to do as homework. Okay. Like this itself, step by step you have to solve and submit in Google Classroom. Thank you and have a great day.